at properties of chords inside a circle. So the property states that if I have a line inside a circle versus a tangent that is outside, the intersection point created by the radius at a 90-degree angle will split my chord in exactly two pieces. So let's do a couple of examples. So here I have a chord and it's split into exactly two pieces, and what you're looking for is to find x and y. So the first thing you need to do is locate again your 90-degree angle right here. And then you know that in a triangle all three angles are always 180 degrees. So if I have 33 already for one and 90 for another, I already have 123. And I know that all three, the missing one that I'm looking for, has to be enough to give me 180. So I can easily see that here it has to be 57. So y would be 57 degrees. Now here, x and 33 are the same. How can I say that? It's because here I have an isosceles triangle. This triangle here is an isosceles triangle, meaning that this angle is equal to that angle. So x is 33 because of isosceles triangle. Let's do another example. So here you're looking to find the length of this chord here, CD. Well, we can do this because we have the diameter, and if we have the diameter, we know that the radius is 13. So I have a right angle triangle here where I can find this side here, the base, by doing 13 squared minus 10 squared, because this is the hypotenuse, and that's going to be equal to x squared. So I have 169 minus 100 equals x squared. So I'm just looking at 69 for x squared. So my side here from E to D would be the square root of 69. The square root of 64 is 8. And the other benchmark I'm going to be using is the square root of 81. Now I know that there's a distance of 5 here and there's a distance of 12 here. So it's a lot closer to 8. So 8.2 would be a good estimation for x. And if I'm looking for the total distance, I know that this is equal to that because the chord is split into two equal parts. So I'm just going to double that. So CD would be equal to double 8 and 2/10, so it would be equal to 16 and 4/10 centimeters. Let's do one final example here. So this question here is you're looking for this distance here. Well, you know that the total distance from there to there is 120, is 20, because it's the same as this one here. And you know that it says here that the surface is 24. Right here, 24 from A to B. So that means that this distance here is 12. So all I need to do is to find the height of the right triangle here and subtract it from 20, and I'm going to get the how deep the water is. So let's do that. 20 squared minus 12 squared equals the height of the triangle. So from here to here. So just h squared. So that's 400 minus 144 equals h squared. So the height from the center to the water. And if I continue along this line here, the difference between these two would be 256, which is a perfect square. If I do the square root, it gives me that the height from the center to the tip of the water is actually 16 centimeters. So if that's 16 and the full distance is 20, that means that what I'm looking for from C to D would be 4. Here's some practice you can do. Make sure you check your work behind the book.